Hi, my name is Juan Nieto, and today I'll be presenting my research on content-based filtering in streaming platforms, specifically looking at the techniques behind it, the challenges it faces, and where I think it's headed. Here's a little roadmap of what we'll cover. We'll start with the problem that makes recommendation systems necessary, and then we'll walk through how content-based filtering works, look at research papers, some case studies, and then I'll share my own proposal for improving these systems. So, why do we even need recommendation systems? Think about this. YouTube gets over 500 hours of video uploaded every single minute. Netflix has over 15,000 titles, and 80% of what people actually watch on Netflix comes directly from its recommendation engines. So without that engine, users would spend more time searching than actually watching. That's the information overload problem, and recommendation systems are the solution. There are three main types: collaborative filtering, which looks at what similar users watched and recommends based on that. It's like the people it's the people like you also watched, you approached. Content-based filtering, which is what this paper focuses on, which analyzes the actual attributes of the content itself, like the genre, cast, and description, and recommends similar items to what you've already watched. And hybrid systems, which combine both. The reason I focus on content-based is because it works without needing any data from other users, so it's more like private friendly. So here's the process at a high level. First, your metadata is extracted from every item: genre, cast, director, description. Secondly, that text gets converted into numerical vectors. Third, a user profile is built from the average of vectors of content they've watched. Fourth, cosine similarity measures how close any given piece of content is to that user profile. And fifth, the top matches get recommended. The whole pipeline works without any other user's data at all. The first paper I reviewed was by Kadka. They built a recommendation engine using TF-IDF, which stands for Term Frequency Inverse Document Frequency, to turn text descriptions into vectors. The idea is that words appearing often in one description but rarely across all descriptions get weighted higher. Then cosine similarity finds that angle between the two vectors. So a score of 1 means identical and 0 means completely unrelated. They tested this on about 5,000 movies and got strong precision and recall results. Importantly, the whole thing runs without any cross-user data. The second paper I looked at was from Sami, published in Scientific Reports by Nature in 2024. They proposed a hybrid model called HRS-IUDL that combines TF-IDF content-based filtering with neural collaborative filtering, recurrent neural networks, and SVD. The key takeaway here is that the content-based filtering is most powerful not by itself, but as one component in the larger architecture. When you add deep learning on top, you can capture patterns that pure metadata analysis can't. And this is probably the most compelling paper I found. A real case study from Netflix presented at ACM Rexus in 2025. When Netflix launched live events, things like sports and comedy specials, they had an issue. No user had ever watched live content on Netflix before, so collaborative filtering had nothing to work with. So their solution was to fall back entirely on content-based signals, so the genre, the performer, the topic, and it worked. They saw a 20% increase in live event engagement across their entire member base, which proves that content-based filtering is a production level infrastructure. I also reviewed a Science Direct paper from 2024 that directly compared content-based and collaborative filtering. The table here summarizes the key differences. Content-based works immediately for new users. It doesn't need cross-user data and performs well with limited data. Collaborative filtering needs a large pool of users to work and has the cold start problem, but content-based has its own weakness, the filter bubble. If all you're recommended is similar content, users never get exposed to things outside of their comfort zone. Which brings me to 4 main challenges. You have the cold start for new content. If a video has no description, there's nothing to build a vector from. Filter bubbles, the system keeps recommending the same type of content. Metadata quality. On all platforms like YouTube, where anyone can upload, there's no enforced standard for tags and descriptions and scalability. So comparing a user's profile against millions of videos in real time is computationally expensive. So for my reflection and proposed improvement, the core limitation of TF-IDF is that it treats words as isolated tokens. If one movie is described as a story about, say, revenge and redemption, and another is about seeking justice, TF-IDF sees these as completely different, but they're about the same themes. My proposal is to replace TF-IDF with embeddings generated by a large language model. The workflow stays kind of the same, and when new content is added, the LLM processes its descriptions and generates a semantic embedding vector. So user profiles are built from averages of those vectors, and then recommendations come from finding the closest items in that embedding space. So there are key advantages. First, semantic understanding. LLMs capture meaning and theme, not just words. So similar content gets similar vectors regardless of the exact wording. Secondly, they're more resilient to sparse metadata. Even a short description gives enough language for the LLM to infer concept type. And third, they reduce filter bubbles because the similarity is based on abstract themes rather than keywords. And a crime drama fan could get a crime documentary that they would have never found otherwise. And fourth, it's feasible at scale. Embeddings only need to be generated once per item and are stored in a vector database. If I were to prototype this would be my plan. I would start with public data sets like Netflix, titles on Kaggle. I would build a TF-IDF baseline first, then generate sentence transformer embeddings using a model like Mini LM. I would build user profiles as weighted averages of those embeddings, and I would compare the two systems using precision at K, recall at K, and diversity metrics to show whether the LLM approach actually reduces filter bubble. And here's my references that I use for my research. And to conclude, content-based filtering is a proven privacy-preserving technique used at scale by platforms like Netflix and YouTube. TF-IDF and cosine similarity work, but are limited by their inability to understand meaning. Deep learning hybrid models can improve the things but add complexity. So my proposed LLM augmented approach addresses the two big weaknesses of filter bubbles and cold start for new content. And as LLMs become more efficient and accessible, I think that the natural step for content-based this would be the best step for content-based recommendation systems. Thank you.